so today we're going to talk about DNA replication. So have you ever wondered how you grow? Well, it's not your cells growing in size because they can only get to a certain size in their lifetimes. Rather, it is your cells duplicating themselves. This process is called cell division. Basically, as the name suggests, the cells are going to divide their organelles into two halves. The parent cell will take one and the daughter cell will take the other half. And so they're going to do this for all the other organelles. But there's one part of the cell they cannot do this with. That part is called the DNA. They can't just cut the DNA and expect both halves to be readable. It's almost like saying you take a document, a paper, with some words on it, and you tear the paper into two halves, and then you throw one half in the trash can, and then expect somebody to read one half and then understand the full document. And so the cells have to duplicate the DNA into two strands so the daughter cell and the parent cell get the same exact DNA. So, how will they do this? Well, to understand, we need to first understand the structure of DNA. So, here I have a strand of DNA, and so I made a video on what is DNA where I described the structure of DNA, and I have it in the suggested and in the link in the description below. So, let me just describe it one more time. So I have an image of the chemical structure of DNA, and we have a nucleotide, and we have nucleotides which are bonded with hydrogen bonds. So let's just look inside these nucleotides. So if we look closely, we can see a phosphate group. And so what is a phosphate group? Well, a phosphate group is when we have 4 oxygen atoms bonded with 1 phosphorus atom. This is going to be bonded to a sugar. And when I say sugar, I don't mean table sugar. I mean some chemical with some carbon atoms, some hydrogen atoms, and some oxygen atoms. And in the case of DNA, this sugar is going to be deoxyribose. Then we have the nitrogenous base. And this nitrogenous base is basically a base, which is a substance that reacts to acids. And as the name suggests, this base is composed of nitrogen. And so here you can see here, one nitrogenous base of DNA is cytosine. And so we have 4 different types. We have adenine, we have thymine, we have cytosine, and we have guanine. And so adenine and thymine are always bonded together, and cytosine and guanine are always bonded together. So if you ever see A on one side of a DNA, then you can be sure that on the other side there will be a T. So keep this in mind because this will be handy soon. Okay, so the first step of DNA replication is DNA unbinding, and we call this the initiation process. And so basically what we're going to do is we're going to use helicase. We're going to use helicase, which is an enzyme, as you can see, ASE, and whenever you see ASE, you can be sure it's an enzyme. So helicase is going to break down the hydrogen bonds of DNA. So it's going to break down these bonds. And so it's going to break these bonds, and then when we do this, we're going to unbind the DNA, and we're going to get 2 half strands of DNA. And so now let's put the letter codes for both strands. And so now the second step, after we did this step, is to match the pairs. And this process is called elongation. And so basically we're going to use DNA polymerase, and DNA polymerase is going to construct the matching pairs to these letters. Like example, G would be C, T would be A. And so it's going to use primase to do this. But so now we run into a problem. And this problem is that if the DNA polymerase on one side is going to be going on this strand, and it's going to be moving in the direction of helicase, and the helicase is unzipping, this strand is called the leading strand. But if you look at the other strand, it's not going to be moving in this direction, rather this direction. So it's going to put CATG, and then it's going to go back, and then do it again from there to here. And so, as we can see, we'll form Okazaki fragments. So, for example, this fragment would be CTAG would be a fragment. And so, why is this? Well, if you can see here, so you look at this image. So, you see the direction of the phosphate groups? Well, they're pointing this direction over here, and they're pointing this direction over here, right? And so, DNA polymerase has to go in the direction of the phosphate groups. And so, it's going to be going in different directions on different sides of the DNA strand. And so how do we solve this problem? Well, what we can do is we can do the third process, termination. And what we're going to do is we're going to use ligase to glue up the Okazaki fragments. And we're going to get two identical strands of DNA. So thank you for watching. I hope you enjoyed this video. As always, watch my video on what is DNA over here, my video on DNA translation over here. Subscribe to Kids Teach Kids, and stay tuned. Bye!